Have you ever wondered what makes a database truly functional beyond just tables and queries? In this video, we delve into the intricate world of database objects that bring scalability, security, and efficiency to data systems. From tables to triggers, discover how each component plays a vital role. Tables form the core storage unit in any relational database. Each table consists of columns with defined data types and rows that represent single data entries. Primary keys uniquely identify records, while foreign keys maintain relationships between tables. This structure not only holds persistent data, but also enforces data integrity through constraints. Imagine a table of employees, each with a distinct ID, name, and department. Views act as virtual tables, simplifying data access without storing data physically. They present results from base tables, making complex joins or filters more user-friendly. Views restrict access to sensitive columns, enhancing security. For instance, a view can present high earners in a company without revealing their exact salaries. This abstraction is vital for reporting and data security. Indexes enhance search speed using B-tree or hash methods. Typically B-tree or hash-based, they can be unique or non-unique. Indexes accelerate queries involving wherever, join, or order by clauses. Imagine searching for an employee by name. An index speeds up this retrieval process. They are crucial for efficient data retrieval in large databases. Stored procedures are named blocks of SQL statements that automate repetitive tasks. They can include control flows like if and LO3 and often accept input parameters. By enforcing business logic on the server side, they enhance security by limiting direct data access. For example, a procedure can update employee salaries with a single command, streamlining operations. Functions, similar to procedures, return a single value and are used in SQL queries. They encapsulate logic for calculations, like tax or bonus computations. Functions are essential for reusable logic in selected queries. Enhancing data manipulation. Imagine a function calculating a 10% bonus based on salary, simplifying payroll calculations. Triggers are SQL blocks that execute automatically in response to specific events like insert or delete. They enforce rules or audit changes without manual intervention. For example, a trigger can log deletions in an audit table, ensuring data integrity. Triggers are powerful tools for maintaining consistency and automating database responses. Schemas act as logical containers grouping related tables, views, and functions. They organize database objects by category, supporting multi-user access and separation of concerns. Permissions can be assigned at the schema level. Enhancing security management. Imagine a human resources schema containing all employee-related data, streamlining access and control. Views simplify complex SQL logic, providing data abstraction and enhancing security. They allow users to access non-confidential columns without exposing sensitive data. Views also offer logical data independence, meaning changes in base tables don't affect dependent applications. This reusability and maintainability make views a powerful tool in database management. Views come in various types, including simple, complex, materialized, and updatable views. Simple views are based on single tables, while complex views involve joins and aggregates. Materialized views store query results physically, improving read speed. Updatable views allow direct data modification, depending on the underlying structure. Each type serves unique purposes in data handling. Functions and procedures organize SQL code, making it efficient and reusable. They encapsulate logic within the database, reducing code duplication. Functions compute values like tax, while procedures perform tasks like updating order statuses. Both enhance maintainability and performance by centralizing logic. This approach streamlines operations and improves database efficiency. Triggers automate database tasks by executing SQL in response to events. They are used for auditing, enforcing business rules, and cascading changes. For example, a trigger can prevent orders for inactive customers or archive data before deletion. These automatic responses ensure data consistency and integrity across the database. Materialized views store data physically, offering fast read performance but requiring refreshes. Non-materialized views run queries live, ensuring real-time data but slower performance. The choice depends on the need for speed versus data freshness. Materialized views suit static reports, while non-materialized views work for dynamic data access. Views encapsulate complex queries, simplifying repeated use and reducing coding errors. Materialized views cache expensive results, speeding up access to aggregated data. They help optimize query plans, enhancing performance. However, they require careful management to avoid stale data. Using views strategically balances performance and data accuracy. While views improve query readability and reuse, they don't inherently boost speed unless materialized. Materialized views need refreshing, adding complexity and storage costs. Non-materialized views run full queries each time, impacting performance. Balancing these trade-offs is crucial, especially in systems with frequent updates or high concurrency. Triggers automate responses to data changes, ensuring consistency and enforcing rules. They can log actions, update related fields, or prevent invalid operations. Triggers centralize rule enforcement, reducing application-side logic. However, they can complicate debugging and impact performance if overused. Effective trigger use enhances database robustness. Views enhance security by restricting user access to sensitive data. They allow selective visibility, presenting only necessary information. For instance, a view can hide employee salaries while showing names and job titles. This control prevents unauthorized data exposure and improves database security. Views are essential for managing access in multi-user environments. Schemas group related database objects, supporting organization and multi-user access. They allow permissions to be set at a higher level, simplifying security management. Schemas separate concerns, making databases more manageable. For example, a finance schema can contain all accounting-related tables and functions, streamlining access and administration. Views, particularly materialized ones, can enhance performance by caching results. However, they add maintenance overhead and storage requirements. Non-materialized views offer real-time data but may slow down queries. Evaluating the specific needs of an application helps determine the best use of views for performance optimization. In real-world applications, views are combined with indexes and query tuning for optimal performance. They provide abstraction and reusability but require careful management. Materialized views are beneficial for static data, while non-materialized views suit dynamic needs. Balancing these aspects ensures efficient and effective database operations. In conclusion, understanding database objects like tables, views, and triggers is crucial for building efficient systems. Each object plays a role in data storage, security, and performance, contributing to the overall integrity and usability of the database. By mastering these components alongside indexes, keys, constraints, and optimization techniques, you can create databases that are robust, scalable, and secure, capable of handling complex business requirements and large-scale data. The knowledge of these elements is essential for any database professional, serving as the foundation for advanced design, tuning, and maintenance practices. Thank you for watching. Understanding database objects like tables, views, and triggers is crucial for building efficient systems. Each object plays a role in data storage, security, and performance. By mastering these components, you can create databases that are robust, scalable, and secure. The knowledge of these elements is essential for any database professional.